And we have one last presentation before lunch, and that will be Benedict Peters, the VP of Marketing at Neul. So Benedict, if you can make your way up here, I'm guessing that's you. It's quite difficult to see everybody here. There we go. He's going to be talking about a dedicated network from M2M to the Internet of Things.
So good afternoon. I know it is definitely afternoon, even though it feels a little bit like it's the middle of the night and we're in a nightclub here at the moment. But my name's Ben Peters, and I work for a company called Neul, who I'm pretty sure not very many of you will have heard of. But hopefully after today you'll have an idea of what we're up to. Have you got the clicker? Somebody, sorry. There you go. Brilliant. Get the technicality sorted out. Good. So Neul is a Cambridge UK-based startup, and we're venture funded, and we've been going since 2010. And essentially, Neul was formed from the key the core founding guys who found a company called Cambridge Silicon Radio (CSR), which is the European fabless semiconductor success story of the last 10 years, really, and the major player in Bluetooth connectivity and Bluetooth chipsets. So the core founding chip team from CSR, our CEO is actually the founder and CEO of a cellular chipset company called Icera that was bought by NVIDIA, actually, in 2011. So we've got this core competence in making super low cost radio chips, and a core competence in the telecoms domain. What we're doing essentially is taking those core competences and building a network for the Internet of Things. So as you will have noticed, we all come from a kind of from a semiconductor background. Myself from NXP, and I think when Neul was founded, it was kind of founded on this idea that actually being in the chip business is not a lot of fun, actually, to be honest. I'm sure there's some people here who'll argue against that, but especially for a startup, actually. So you spend a hell of a lot of money developing chips, even more money developing the software that goes on those chips, and in the end, then you turn up to an OEM, and they basically look at how big your die is and say, well, the cost of silicon is so much per square millimeter, and that's what we're going to pay you for your chip, basically. So VCs are quite well aware of that, and it's quite difficult, actually. If you're a company now that wants to start, if you're a bunch of guys that wants to start a fabulous semiconductor company, it's very difficult to get funded. So at its essence, Neul is basically a company which is core competence in making chips, but is turning the whole chip business model on its head, so that we will continue to make chips, we continue to design chips, and in a kind of fabulous mode, but actually we will get paid from the revenue that those chips go on to generate as a service, and I'll go into some details about that. So we're a fairly small company, growing pretty rapidly. We're about 30 people at the moment, and we're doing a whole bunch of stuff, probably too much, actually, to be honest, but we're doing a whole load of stuff. So we're developing a new air interface for the Internet of Things, a new standard that we set up in a special interest group. More on that later. We've developed base station technology, and we're leasing those to network operators. We've developed the chips that go in endpoints, and we've developed the endpoint module that goes around that chip. And we have developed as well the cloud core network that controls all those base stations and delivers the data to customers in a connected device platform. So a whole bunch of stuff. So I thought, I appreciate this is an Internet of Things event, and I'm probably talking to the converted here, actually, preaching to the converted a bit. But I thought it's interesting to start with this slide, actually. So I think the Internet of Things opportunity it's definitely exciting. Obviously, we're a startup, so we're obviously pretty excited by it. But it's it's really, really confusing as well. There's some of the discussions this morning have really sort of accentuated that. Really, there's a ton of players. It's lots of connectivity players, lots of application players, lots of different verticals. It's not 100% clear what business models are going to work, what pricing models are going to work. So it's a massively complex beast. And Gartner puts it actually on coming up to this peak of inflated expectations, which is, as you can imagine, is exactly the place we don't really want to be when we're talking with VCs trying to get funding. But actually, we sort of pitch that we can skip this trough of disillusionment, and we can move straight into the plateau of productivity. But the important thing on this slide really is that the Gartner say that this is going to reach, so it's going to take more than 10 years before the Internet of Things reaches this plateau of productivity. So it's a massive topic now, and it's whatever way you look at it, it's going to be a massive topic for the next 10 years. So it's absolutely a good industry to be in. So just to recap really on what Neul thinks, how we see the Internet of Things. So things could be anything. So, we typically, as a connectivity company, talk about connected things. So you think about vending machines, you think about parking sensors, you think about, smart dustbins, water pumps that are connected, all these kind of things. But it can also be things that aren't typically connected. So fast-moving consumer goods, for example, a couple of examples here of luxury products. And these things somehow have an online persistent digital identity. This is a massive thing at some of the previous events that we've been to this month, actually, in that just like we personally have a LinkedIn or a Facebook profile, a thing should have an online profile in the cloud. And that's always there. So you can write applications which constantly talk to that thing. It's got a persistent presence. And then you've got some devices which are connected and essentially can give status updates to their online profile. And you've got other devices which are just linked via a QR code. So you take your fast-moving consumer goods, and they might have a unique QR code on it, and you rock up with your smartphone, scan that QR code, and then that online presence of the thing notes the location that's taken from your smartphone. So these things in the cloud are then the basis around which people can write applications. So we talked a bit about big data analytics this morning. There's a whole ton of stuff you can do there. And in essence, all of this is about capturing things, so capturing data from things, connecting with it, and then acting on it, with the end game, really, that we can develop new services, we can reduce costs. So a lot of the early stuff is really about reducing operational costs, improving operational efficiency, but overall, that we can achieve a better quality of life. So these things that are connected, what should the connectivity look like for these things? So you can sort of group the kinds of connectivity options into personal area networks. So things like Bluetooth Low Energy, for example, is a good personal area network technology. It's pretty low cost, so you can get endpoints for sub $5, and you can do pretty well with battery life. So you can get more than a year battery life out of a BLE device. But it's not ubiquitous. So if you've got it works quite well for your Fitbit that's talking with your smartphone, but it relies on having a smartphone or an aggregation point to connect it to the internet. And it's not there yet in terms of simplicity. So because of that connection, because you need to connect it to a smartphone or something, it's quite complicated if you're going to roll stuff out en masse. Local area networks, so think Wi-Fi, that kind of thing, really. Again, low cost, but for much of the same reasons. It's not ubiquitous. It's a pain to do network planning. If you're a facilities management company that wants to track the level in your soap dispensers, which is a very crude example, a mundane example, but a real application, it's a real pain in the arse because you've got to go out there and you've got to put a Wi-Fi access point up. You can't hop onto the Wi-Fi access point that's provided in the building already. You've got to have your own thing there, and then you've got to organise backhaul from that. So it's a bit of a pain. It's difficult to achieve really long battery life, and it's not very simple. So I think most of these applications would prefer to have a wide area network connection. So a network that is just there, and you rock up with your device, and wherever it is, it connects. And cellular goes some of the way to doing that at the moment. So it's got 96% population coverage. When you talk about thing coverage, it's much, much worse, which is evident, actually, if you see the kind of things that are happening for the DEC smart metering program in the UK. So it's getting there with coverage, but it needs to be better. But I guess the main issues with it are it's not really low cost. So you can get GPRS modules now for about $12 in volume. But that's not the price point that we need to really sort of explode this market. It really needs to be sub $5. The battery life is a problem because these cellular modems, be that GPRS or LTE, they're having to wake up very often to talk with the network because the whole system is architected around the point that if I want to call Joe Bloggs on his mobile phone, I make that call and I can't be waiting around for 15 minutes waiting for him to pick up. So it needs to be quite immediate. And it's a fragmented ecosystem at the moment. So every time you want to do something, take again the facilities management example, that in itself is a mini systems integration project, which just makes it expensive and complicated. So what we're doing at Neul is we're trying to address all these things. So we're trying to design the architect the system so that we can have super low cost endpoints, and I'll come on to that in a moment. We need much better link budget than GPRS. So again, I know the example is fairly crude. You take your soap dispenser. If you or I want to make a mobile phone call, and we're in a building with pretty poor coverage, we naturally go up to the window and start talking close to the window to get a better connection. You can't do that with a soap dispenser, for example. So that has got a place on the wall that it needs to be, and you have to make sure that you get connectivity to it. So we've taken some trade-offs so that we can get much, much better link budget than you get with GPRS. We take other trade-offs in terms of long discontinuous receive cycles, which basically means that the device is not talking with the network so often. So in a typical GPRS system, an endpoint might wake up every 470 milliseconds and talk with the network. In a typical Neul weightless system, you might not wake up until every 18 minutes or in some cases even longer. And we are really delivering everything from the endpoint to the point in the cloud where you collect the data. And by doing that, by having ownership of both ends, we're able to make it really super simple so that anyone can use it. Good. So wide area networking, how big is it? So this is actually this is taking some data actually from Machina actually. You can see, so where we're at today at the moment, we've got about 143 million cellular connections, and the mass of the market is, of course, local area networking or personal area networking. And you can see by 2020, of course, there's going to be a massive growth in Bluetooth, in NFC, and Zigbee, but there's also going to be a massive growth in wide area networking. And a massive chunk of that is really suitable for, and will only be enabled by low power wide area networking, which is exactly what we're delivering. So essentially, what we're doing at Neul is we are bolting two distinct technology capabilities together. So you've got, on the one hand, you've got this super lightweight, flexible, wide area networking air interface that we call Weightless. And we're bolting that together with a cloud core network and connected device platform capability. And the marriage value of those two things means that we can have super simple systems and we can deliver it really low cost to the end user. So back to this theme that I really think the Internet of Things is mega complicated. I tried to draw a bit of an ecosystem map to sort of map out where we think we fit in this ecosystem. So you've got connectivity plays. So here you've got local area networking, personal area networking that we've talked about a fair bit. Cellular, of course, and you've got low power WAN, which is what I was just talking about. You've got then edge aggregation plays where you're doing lots of processing on the edge. You've got connected device platforms, which could be for a variety of connectivity types. You've got, on top of that, you've got visualization and toolkit plays. You've got then application enablement platforms, where I know a few of the guys are here today as well. You've then got big data analytics that sits on top of that. And then you've got a whole ton of vertical market plays, which tend to be quite small companies that are doing very, very specific things. And then you've got companies that play completely from top to bottom. So you take, especially in metering, in regulated type verticals, that's quite often the case, that you have people playing from top to bottom. So in the connectivity side, you've got Qualcomm, of course, doing lots of stuff in cellular, and with their Atheros purchase, they're playing in Wi-Fi. You've got Intel, who's with the Quark processor, is concentrating on the edge play. You've got Jasper, who I know are here today as well, who are doing the connected device platform for the existing cellular standards. And you've got Xively and Electric Imp. Electric Imp have got some interesting stuff for Wi-Fi and a very neat visualization layer. You've got ThingWorx, who are here today as well, who are doing the application enablement platform, which would sit on top of our stuff or other cellular standards. And then you've got a whole bunch of vertical players who are sort of quite niche. And the sort of end-to-end vertical plays are guys like Silver Spring or Census. And where Neul really fits in is actually here on the low-power wide area networking side, and on a connected device platform that sits on top of that. And we're not doing any of the other stuff. So, I mean, to be absolutely clear about that, we will partner with other people to deliver the other stuff, but that is in itself a whole lot of stuff to do. So, yeah. So Weightless, I know Gary's going to talk about it from ARM. He's going to talk about it a little bit later on as well. But Weightless is a special interest group set up to define this air interface standard that I was talking about. So we're perfectly well aware at Neul that if this was going to take off in a big way, then it needs to be an open standard, and there needs to be lots of people implementing it, and it can't be a proprietary Neul solution. So the idea behind Weightless is it's simpler than 2G. It's lighter weight than 3G, 4G, and it's much lower cost, and therefore it's 0G, and therefore we call it Weightless. And it's together with the other promoter members, so ARM, Accenture, Cable and Wireless, and CSR. What we've done essentially is taken a bunch of pragmatic decisions about what this air interface should look like for the Internet of Things. So it's not a massively inventive air interface standard. It's using modulation schemes and coding methods that have been pretty well proven over the last sort of 25 years. And it's taking this pragmatic set of choices and trade-offs, like saying things like, whereas in the cellular world, you're quite keen that if you move between cells, that your mobile phone call isn't disrupted. In machine communications, handover between cells can take a bit longer. And it can take, you can live with significantly longer latencies for a lot of Internet of Things applications than you would do with 2G or 3G, for example. And that air interface standard is applicable to all sorts of different spectrum, which I'll come on to in a moment. It's going pretty strong. So we had the first Weightless Summit earlier this year. We've got over 1,200 members in that group. And we've got the version 1.0 of the spec ratified already. So that's a real spec that can be implemented. So a bit more detail about where that might sit, because I know Ewan was mentioning before, that we're the TV whitespace company. Well, we are a TV whitespace company. We can operate this air interface in TV whitespace. We can also operate it in a bunch of other spectrum, and some of that is potentially more interesting even. So you take there's the TV whitespace spectrum, which is essentially going to be run as license exempt. But there's also all over the place really interesting bits of sub-gigahertz spectrum, which we will put weightless into. So there's things, for example, in the US in the PLMR bands, but there's also bits of cellular spectrum even, like guard bands or GSM subcarriers, which we could potentially fit weightless into. So it only needs a very, very small amount of spectrum. So we only need about 200 kilohertz of spectrum. And then we divide down that spectrum into a few subchannels for downlink and a whole lot of subchannels for uplink, because it's a TDD-based system. And we can design modules which have multi-band capability. So Bosch could put this in their washing machine, for example, and not care in what country that washing machine ends up. The module will be capable of operating on whatever spectrum is in use in whichever country. So to give you an idea of what the system looks like, on the endpoint, you have the endpoints which at the moment are supplied by Neul and will in a short period of time, probably by the end of next year, be supplied by other module vendors as well. And these have a really super simple API on them. So simple that I've said before that children can program it, but actually I'm quite aware that children are quite good at programming. So simple that my mum could program it. That then also includes the full weightless stack, so it can handle talking with the network. We supply we lease these base stations to network operators, and these base stations are put down in a similar cell pattern to GSM 900. So you're talking about in urban environments, you're talking about cell sizes of about 1.4, 1.5 kilometers. In rural environments, you're talking about much bigger cell sizes, so you've got a cell radius of 8, 9, 10 kilometers in a rural environment. They're dead easy to deploy, zero-touch deployment, so you've literally just bung an Ethernet cable in them. They can be deployed on macro cell sites, so existing macro cell infrastructure, but also they can be deployed on street furniture as well. And they look very similar, actually, in terms of form factor. It's difficult to get an idea from that, but they look very similar to a Cisco wireless access point, these things that are being put up all around London at the moment. So that's how you deploy the base stations. They then talk with this connected device platform, and that connected device platform has all of the capability in the APIs, so that network operators can monitor the health of the network, so that they can get all the billing records, so that they can enforce policies on specific end users, and it also provides the super simple APIs to the end user, so that they can very simply just get or push data out to their devices. And on top of that connected device platform, you might have something like the ThingWorks platform, or you might have a wrapper that then incorporates that into an ERP or a Salesforce.com or something like that. So module-wise, I've got a module in my pocket actually, just to show you this is not this is real. So this is the current module which we have based on our existing silicon. We're just taping out the next version of that chip actually, which will bring the form factor down dramatically. So we'll go from about 45 mil by 35 mil where we're at today, down to about 20 by 20, and that will put us in the realm of about $9. And the next step is actually to do more integration on this, so we're integrating the microcontroller and some of the RF parts into that chip, which puts us safely into a $4 module, which is about the size of a postage stamp. And all you need to add to that module is a small antenna and a battery, and there you go. You've got an Internet of Things connectivity. So we are deploying these networks throughout 2014. So we will have a network in London. We will also have a few incubator networks throughout the US and a couple in Southeast Asia throughout 2014. Really focusing on these incubator networks at first, so that people can start to build applications around that. And some of those applications, I mean, it's just endless. Literally every day new people come to us with ideas for applications that could be enabled by the fact that these things are so low cost and so low power. But to give you some idea, we talked a lot about facilities management. I mean, the business case is just so easy to make there for improvements in operational efficiency. But there's a whole bunch of stuff also in intelligent buildings and in transport and traffic management, which we're working on at the moment. So yeah, I think that's the last slide. So yeah, I hope that was interesting, and thanks very much for your time.
How can you build a network having operators? Are you going to work with operators? They will be your partners, or they will be your enemies?
No, they'll be our partners for sure. So our model is similar to how Ericsson work at the moment. You can see us as quite similar to an Ericsson, although a little bit smaller at the moment. So in that we lease these base stations to network operators, and we provide the software smarts, which would typically be cloud hosted because that's how we get the real efficiency gains, but could also potentially eventually be hosted in the operator NOC. But the operator is absolutely the channel to the market, and we are a technology provider to those operators.
What kind of upload and download speeds do you support?
So we can support similar speeds to GPRS, but actually that depends where you are in the cell. So if you're right on the edge of the cell, it uses adaptive modulation and adaptive spreading factors, so that right on the edge of the cell you might be capped at more like 10 kilobits per second, and just so that you've got the link budget to get through to that device. I mean, the more we learn about the Internet of Things market, it's not actually, for many of these applications, it's not really about the point data rate that you get to a device. It's just, it has to be up, we have to get 20 bytes of user data, something like 20 times a day, and it doesn't matter if it takes 3 seconds or 3 minutes to get that data across, but we need to make sure that we can give that quality of service, and we can definitely get that data across.
Thank you very much.
Thanks a lot.